we're talking about geometry and trigonometry 2, three-dimensional shapes. Now, these topics, these concepts are still going to cover geometry and trigonometry 1 with SOHCAHTOA, sine rule, cosine rule, area, and things like that. But we're looking at three-dimensional shapes as well. So if you had some issue last unit, we'll be going back over that concept and adding something a little extra. Okay, so you'll get double the practice. So you'll be able to identify the different three-dimensional solids that there are, and at least that we'll cover in this class, and you'll find distances between points, as well as finding their angle measures between different planes and lines of these solids. So first, let's review what a solid is. You would have covered this back in geometry. You have, in this case, you have a cuboid, basically a rectangular prism, okay, or a square prism. You have your faces, which basically make up the figure. Your faces are connected with edges, and each edge intersects at a vertex, or if it's plural, vertices. Okay? This is your general makeup of any solid. You'll have faces. They could be plane shaped, they could be curved. Where your faces meet, they're known as edges. Those are your flat sides, and then of course all your edges meet at a vertex. Those are the red dots there. Now, if you have your different types of solids, and if you cut parallel to the end face of a right prism or a pyramid or a cylinder or a sphere, so on and so forth, the cross section will always be the same shape and the same size. So if you take a look at this cube here, and you cut it, think of all these like blocks of cheese. Okay? You got a cube type of cheese. You cut it with a knife. What is that cross section going to be? Square. It's going to be a square. Okay? You cut it parallel, it'll be the same size and shape as the figure itself. When you cut a cylinder, it's going to be a circle. All right? What about when you cut a sphere? Circle. It's still going to be a circle. And everybody, these words that I'm using, like cylinder and sphere, you've heard these words before, yes?
Yeah.
Good. What is this? What is it? This in D. What's that called? This is a triangular prism. And when you cut a triangular prism, it creates a what?
Triangle.
It does create a triangle. This is known as a square pyramid. Remember the square base, but a square pyramid. When you cut a square pyramid, the way that the knife is cutting it, what does it create? It creates a square. But what if you cut it? Well, never mind. It's parallel to the base. What is this figure?
Pentagonal prism.
A pentagonal prism. When you cut a pentagonal prism parallel to its end face, it creates a what? It creates a pentagon. And the last one?
True enough.
Say it again. Yes, because all you're basically doing is you're creating two pieces of these prisms or these cylinders or whatever. But the face that is created when you cut it, so you cut through, like a butter or something, and you pull out that face that's there is basically the same shape as the face. Okay? So we're good with this?
Sure.
Any of this unfamiliar territory?
No.
Good? Okay. Now, pyramids. Pyramids. The base of the pyramid is always a polygon, okay? So in this particular case, the one on the left, that base is a what?
Rectangle.
A rectangle. So this will be known as a
Rectangular prism. Not pyramid.
A rectangular pyramid. This one is a what?
Pentagonal.
Pentagonal pyramid, okay? So it's always named based off of this base. Now the faces of a prism, besides the base, are going to be triangles, and they meet at a point. This point is called your apex, okay? Also known as a vertex. So don't get confused by the language. Apex just means the point where all the triangular faces meet. And in a right pyramid, the apex is always vertically above the center of the base, which means that this line, this red line in both these cases, is going to be what to the base? Your height, and it's going to be what to the base? Say again?
Perpendicular.
Perpendicular is going to worry about your right prisms or your right pyramids or your right cones and your right cylinders. You're not going to be dealing with any oblique ones, okay? So they're all going to be 90 degrees, okay? Questions? Going through a lot of vocabulary, terminology before we actually get to the examples. Are we good?
We're good.
All right. So again, you can have two different groups of solids. You can have ones where all their faces are planes. These are your prisms and your pyramids. So basically all of your faces, all of your surfaces are flat. Or you can have the ones that you have at least one curved face. Those are your cylinders, those are your cones, and those are your spheres, okay? So you can have those types of, two different types of solids, or groups of solids. Your sphere has one curved face. Hemisphere, that is half of a sphere. It has two faces, one plane, one curved. Okay, everybody follow me here? A cylinder has three faces, two planes, and one curve. The two planes are the two bases, the curve is the one. And a cone has two faces, one plane being the base and one curve being the top. Okay? Here we go.
I do.
It says the diagram. Now we're getting to the examples. Okay? Get into examples. The diagram shows a cuboid, A, B, C, D, E, G, F, G, H, where AG is 7 centimeters, DC is 4 centimeters, and CG is 3 centimeters. Okay? And we have to find the length of these segments here. Now, you guys have the space above the notes and below it, okay? Make it fit. Okay, I was able to make mine fit, so you guys make yours fit. All right, we got to find the length of AH. AH, there's no segment that's already drawn on the picture, so just for right now, so that you guys can visually see it, you can do it on yours. Not necessarily saying that you have to, because I'm going to redraw the triangle that's created. So, AH is this segment right here. The key is that when you're trying to find these lengths, is you want to create your right triangle, okay? Because every one of these segments that's drawn inside of a solid can create a right triangle or a non-right triangle where you can use sine rule and cosine rule. Does everybody see their right triangle? What are the other two sides that make up the right triangle?
7 and 3. 7 and 3.
Yep, you have the AD segment that's 7, and then you have the DH segment that is 3. This is a right triangle because all of these are right solids. So to find the length of AH, what do you use?
Put that.
So AH squared is going to equal 3 squared plus 7 squared. What's 3 squared plus 7 squared?
58.
So to solve this, you have to end up doing what?
Square rooting 58.
Taking the square root of 58, and then of course you can leave it like this. This is known as the exact answer, and then just putting your units on it. But you do have the option to round to 3 significant figures, and you get what?
7.62.
Can I get some confirmation, or do I need to do it myself?
7.62.
All right. So the trick is to figure out the right triangle, and then perform your Pythagorean theorem. So I want you guys to go ahead and do that for AC, DG, and AG. Go ahead and do that now. All right, so here we go. Define AC. AC is this segment right here. So what was your right triangle that you used to find AC?
Right triangle.
A.
74.
Very good. So this would have been 7 and 4. So again, you would have to do Pythagorean theorem to figure out AC. So you would have had 7 squared plus 4 squared. What is that? Give me the 65. So you would have taken the square root of it. You could have left it like this, square root of 65 centimeters. If you rounded, it would have been what? 8.06 centimeters. Please make sure you include your units so you lose those unit penalties.
Oh, stop.
All right. Now to find DG. DG is located right here. What triangle did you use to
BCG.
So here is B, here's G. and C, so that would have been 4 and 3. Hopefully you've done enough of these triangles to realize without doing any work that what is the length of DG? It's a Pythagorean triple, guys. Okay?
It's a trip.
You always
If the two legs are 3 and 4, the hypotenuse will always be 5. And now for the last one. The last one was a little different. Why was it a little different?
Because
Because
it's not on one plane.
Cross.
It's not on one plane.
You need one of your answers, for sure. You need the midpoint of AD and the midpoint of CG. Right? AD and CG. So you needed this segment right here. What did you use? What did you use? We're doing
We're on 4. We're on IV.
So we're trying to find oh, my bad. I jumped ahead. I'm sorry. I jumped ahead. Sorry, I jumped ahead. AG. Where's AG?
Wait, were we supposed to do this?
No. Like I said, I just jumped ahead. My mistake. Alright, so AG. What did you use for your triangle?
AGD.
It would have had to been this one. Did you guys use this one? ACG? There's your right angle right there, ACG. And you would have had to use your answer from part double I, which is the square root of 65, to figure out AG. And hopefully you use square root of 65 or the long decimal, not 8.06. Okay? So AG squared equals the square root of 65 squared. What happens when you square a square root? It's a whole number. So this turns into 65 plus, which is what's 65 plus 9? 74. So you're going to take the square root of 74 to get your answer, which is what? 8 point what?
6, 0.
So my triangle worked too if I use ADG, because I can use DG, which was 5 and then 7. Cool.
Because no matter what, it's going to create a 93 answer. Question on these 4. I'm going to have to clear my screen to go to do the I double I.
How did you get square root of 65?
That was from back here. It was the exact answer.
You use the long one, no.
You get the diagonal
But so the AD equals AC.
No.
To find AC, we use this bottom triangle, ADC. Okay? In part B. And so then we use that same segment and then CG to find AG. So we have to find the distance between the midpoint of CG and A. Is everyone good? So like I said, I'm going to have to clear this.
We're good.
All right. So the midpoint of CG is here. Let's label that N. And A. So we have to find this distance. Yep. So I'm going to definitely use this part. Okay, and then maybe connect these here. Is that fine for you guys? I mean, you can make another triangle another way. As long as we do the same answer, then we're good. So that's triangle A and C. And if you realize, I'm rewriting every single triangle. So in that way, we're not getting confused or anything. NC is 1.5 because it's half of 3. And then what was AC again? So we got the Pythagorean theorem of this. What is that before you take the square root? So then when I take the square root of it, I get a decimal approximation. What's that? 8.20. Confirmation?
Yeah. Yeah.
Questions? And now for the last one, we have to go from the midpoint of AD to the midpoint of CG. So, AD, CG. What triangle do you want to create? What other segments are we going to use?
MC, CN.
So, MC and CN. We already know that CN is how long?
1.5.
But what is MC? How do you get it? Do you know it off gate? Is it half of a number or?
Is it half a square
7
root?
divided by
3.5 is this segment right here.
Is it the half?
So it's gotta be half of the
Square root.
8 point.
2. No, you have to, it's another right triangle, so you have to do the Pythagorean theorem for that one. And then you,
Oh my lord.
You have to do another right triangle to find MC to figure out MN. Okay? So yes, the distance from M to D is half of 7. That's 3.5. But that is MD, not MC. We know that DC is 4, so it's another Pythagorean theorem here. Okay? So MC squared. But don't we have to use it to answer the next, like, the original problem?
Yeah, so then it would be 5.3 squared plus 3 squared. No, 1.5 squared.
What's 3.5 squared plus 4 squared?
It's like 28.25.
28.25, and we have to take the square root of it to get the length of MC, don't we?
Yeah.
So use that. Use the square root of 28.25 as the length for MC. Because we have to use that answer to answer the original problem.
Hey,
Go ahead.
you 3.5 squared plus 4 squared equals 28.25, and you square root of that. That's 5.31.
It's some decimal.
Right.
But because we don't want to use the rounded answer, we want to use the most exact answer, which is just the square root of 28.25. We use that in this triangle, so that way we can figure out the length of
But
it.
you're gonna square that anyway. So
Let's see if we square the three significant figure. What's it exact?
no, yeah, I kept it.
Oh,
Yeah.
So what is this? Is that before? I always want the exact value before you give me the solution.
Yeah, that's before it's like 5.5.
When you add it to 1.2.
Yeah. Oh.
This right here is the exact answer. Okay, 30.5 is the exact answer. Now what's the three significant figure answer? Questions? Alright, so you have to find AC.
Sorry, guys.
That created a right triangle. What was the hypotenuse of this right triangle? What letters represent the hypotenuse of the right triangle? AC.
Oh yeah.
And then what was this?
AC.
oh, I just put like a random.
What? Hold on.
Wait.
Okay. AC is this segment right here. So I'm asking you, what was the right
Oh.
triangle
I
that
did.
you used?
Oh, 85.
Oh, I put a random point
Yeah.
above the next to E.
Yeah. And then it was 8 at the bottom and 5 on the top.
That's-
I don't know why I did that.
D. Yes. Okay. So So then it would have been 8 and 5. Yes, because it's a square pyramid, so you know that those two are the same measure. So you had to do your Pythagorean theorem. 8 squared plus 5 squared, and I want the exact answer before you give me the rounded approximation. It was the square root of what?
89.
And that was about what?
9.43 centimeters. 9.43.
It should have been 4-3.
Correct.
4-3. If you round the three
I said
significant figures.
He said 4-3.
He said
Okay.
4.3. Okay, it's 4.3.
Now to find B.
He said 4.3.
B is EC. Okay, B is EC. So you're looking for this link right here. Okay? Now my question is, what is the other point on this right triangle that you used? Oh, very good. It was this triangle right here.
Oh, I swear I thought she was.
That's right.
You thought C was a
Yeah. I thought he was the
Okay. Just quick question. Do you guys read this
No.
one?
No.
You know, they tell me
Because it tells you that the height is OE, so O would have been the one in the middle.
Why read down whenever you have all the information on the triangle itself?
It looks like
Because you can't read the triangle. That's what
Can't
you
read
say.
the triangle.
What? What is EO? 7. And what is OC?
9.4.
See, that's the word. That's half of square root of 89.
Half the square root of 89. So when you do your Pythagorean theorem, EC would have equaled 7 squared plus the square root of 89 over 2 squared. And what's that answer before you type into your calculator and round the three significant figures? Which was about what?
Just keep it as the exact answer.
But you can keep it as the exact answer as long as you put your units on it. That's what I think. Questions on that? Yes.
Why you put the 89 or 2 again? How was that thing?
Because OC is half of AC. And since we found AC in part A, and it was the square root of 89, it's the square root of 89 over 2. Stop. And now the last one is EM, which is the midpoint of CD. So we have the midpoint of CD. EM is going right along that face. What is the other point that makes the right triangle? O. So, how long is MO?
Half of square root of 89.
It's 4.
It's 4.
No, it's 4. Because it's half.
It's half of AD. So that's 4. You know, this is 7. So EM is basically those two squared. What is that before you type into your calculator and round? Square root of 65, which is about 8.07. Question? Oh, it's not happening. So, to calculate angles, we're going to identify the right triangles, then use trigonometry, okay? So this is very important. We've got to make sure that we can figure out what angle the problem is asking us to find, so then that way we know what sides to use, and then, of course, subtotal or sine or cosine. So we're going to practice this just to be sure, okay? We're going to practice just to be sure. We are going to use the cuboids that are shown in each one of these problems, and we're going to mark the angles that are being described. It says the angle that the plane ADHE makes with the line AG. We need to figure out what that angle is. Okay?
It's probably the one missing verse.
Context clues.
It's probably right there.
And he's missing the all or whatever. Alright. So, ADHE and the line AG. Well, we have a line. Let's go ahead and draw we basically need to draw a segment across that plane to create the angle that they're asking us to find. That segment is going to run from A to what? H.
Oh, I'm sorry.
And that is the angle that they're asking us to find. Now, even though it doesn't ask us to do this, I want us just to be clear, because in order to figure out this angle, say we were given some more information, we would need this right here, this right triangle, to do that. Does everybody see that? So what I want you guys to do is go through C, D, and B, C, and D, and I want you to draw on each of those cuboids the angle that they're asking you to find. All right, let's go over these. Okay, so we have line AC is intersecting plane ADHE. Okay? You have to form an angle here that this plane makes with that line. The segment that creates the angle is
You have little blocks.
AD.
Blocks?
That angle right there.
What the world?
Okay? Because remember, you're trying to form a right triangle. And the only way that you're going to get a 90-degree angle is if you have that perpendicular from C to D. Okay? From C to D. Did everybody get that one? If you didn't, just think of it in the room, okay? You have to create a right triangle. If you have a diagonal going across the wall, you have to create a 90-degree angle.
These blocks.
Blocks.
It's a room.
The rules is the
room.
room. And this is why I don't. The angle between lines BH and HA. This one should have been a little bit easier to see because you're just looking at the two lines, BH and HA. There's your angle. Your right triangle would be here. Okay? You guys want to practice some more. You have 4 more.
So all those like markers, like you put them like that is the right triangle. You count that wrong.
What do you mean?
Like you just said, you don't put that as the right triangle. You do that on.
No, this right here is just the answer, just that curved part. But later on, you're going to have to figure out what that angle actually is, and you have to be able to identify the right triangle. All right, you're doing the next 4. For this one, you should have had DE going along the side and the bottom plane to create your right triangle. You should have had that one there. For B, the bottom plane makes with NE, which is the midpoint. We've had practice with this. It should have been this triangle here. Sorry, let me reiterate. It's this angle and then this angle here. I apologize. Okay? For the last 2, BE, ED, this one here, this one's not going to create a right triangle. So what do you think you would have to use to figure out this angle up here? Sine rule or cosine rule, depending on what they give you. And lastly, DE and EC. Does this create a right triangle? No. So you would have to use sine rule or cosine rule.